So here are the steps to solving a system by substitution. I'll be honest, I'm not the type to really follow step-by-steps, because unless you carry around a list with you of step-by-step instructions all the time, that's just not how life works, and you won't have step-by-steps on the ACT. So I try to make more sense of the problem. And so we'll just start with number one, but you can read through the step-by-steps yourself. Let's say I tell you that a number equals another number, but then that same number equals a whole different number. So if A equals B and A equals C, what can I also say? Well, if B equals A and C equals A, then that means that B must also equal C. Yeah, good. B equals C, and someone typed that in. Good job, Jaden. So yeah, that was just substitution. So what we did is we substituted this into the A, and then we got B equals C. So that's the property of substitution. Number two, we have y equals 2x plus 1. That's a line. It starts at 1, goes up 2 over 1, has many coordinates that work. One second. And then we have another line that starts at -4. Oh, are you looking for breakfast? Oh, I don't have a breakfast class. And then we have another line that starts at -4. Sorry, there might be interruptions. I am at Truman, and people do walk in. So this one starts at -4 and goes up 3 over 1. So we have these two lines, and just drawing a rough sketch, one would be like this, and then one would be kind of like this. Not exactly horizontal. I should have drew that with more of a slope, but they intersect somewhere. And where they intersect is at the same x and y value. So even though these x and y values don't have to be the same, they're two different lines. If we're trying to find the solution, we do want the x's to be the same. We do want the y's to be the same. So by being a solution, the y value and x value should be the same value. So if I have y equals and I have y equals, well, couldn't I just take this and plug it in for y? Because y is 2x plus 1. And then you get 2x plus 1 equals 3x minus 4. From there, we're down to Algebra 1 skills. We have one equation with just one variable. And so I'm going to go through this part a little faster so we can focus on the important skill. But from here to solve this, there's many different ways. Probably the way I would do it is take away 2x from both sides. And then I get 1 equals x minus 4. And then from there, I would add 4 to both sides. And I get x is 5. So what that means is the x value right here is 5. And we need to find the y value. So they intersect 5 over. To find the y value, you pick either equation. It doesn't really matter in this case. And you just plug 5 in for x, and that'll spit out the y. So 2 times 5 is 10, plus 1 is 11. So I would say 511. Notice when I plug 5 in here, I should also get 11. 3 times 5 is 15. 15 minus 4 is 11. So I just found that they intersect at 5, 11. And then I'll show notes for that. So when you plug back in, you plug in the 5 for x, and you get y is 11. And these are not, I like to separate those so it doesn't look like it's all combined. Now, notice most of our graph paper that at least most teachers hand out stops at 10. So if we had tried to solve this by graphing, it may, depending on your graph paper, not have fit on the graph anyway. And so that's why it's good to know other methods besides graphing. Substitution works for almost anything in math. Graphing is good. And then let me just go check my answer real fast. Let's see where these things cross. I'm using Desmos graphing calculator. And I'm going to type this in. It's more so for like visual learners. Notice they cross, intersect, I should say, at 511. And I think if I click here, I'm new to Desmos, it tells you the coordinate, so it intersects at 511. So you could have solved this by graphing, and then yet there's another way I'm going to show you the next class period, which is, looks like our next class after this is Wednesday, September 9th, based off the calendar I have on my board. So this Monday is Labor Day. Of course, like you don't have to do any work on Labor Day. And then Tuesday is an odd day, and then Wednesday would be even. So I'll see you Wednesday is our next class. And if you have any questions, just feel free to type them in. All right, here we have x equals x equals. Careful graphing this, you cannot type in x equals in the Desmos to my understanding. But what you would do is you could just set them equal to each other. Then you would find the y value and then plug back in to find the x value. Okay, I'll let you do that one by yourself for practice. I want to make sure I show examples for every single type. So that one's just like this one. It's just x equals instead of y equals. These are the same thing. Y equals, so just set them equal to each other. And then you would solve for x and then find your value of y. If we have time, I might come back and do one of these. What I really need to make sure I do is what happens when you don't have, we call that isolated. So you may not have even known what that word isolation meant until this whole COVID thing, but you know, isolation means like you're by yourself. And so when you're solving, you should have a variable by itself. So I have y equals x plus 1. I would say that y is isolated. Here, x and y are together, so I would say that they are not isolated. And so the steps, and you'll find those in the notes, is you want to take the one that's isolated, which would be this one. And so that's y is x plus 1. So I could plug that right here. And I would get 4x plus, now be careful plugging in. Anytime you plug in, you should put it in parentheses. So notice all I did was I took this second equation, and instead of putting y, I put x plus 1 because y is x plus 1. Now here, usually there's a number out front here, and you would distribute. There isn't a number to distribute. I guess you could think of it as like 1, But what we can do is we could just drop the parentheses because multiplying by 1 doesn't do anything. So now I get 4x plus x plus 1 is 6. And then from there, we're down to algebra 1. So I'm going to move a little faster so we can cover more examples. 4x plus x is 5x. I subtract 1 from both sides. I divide both sides by 5. And I get x is 1. So they intersect when the x value is 1. How do you find the y value? You pick either equation and you substitute the value of x in, since that's what I just found, to find the y value. This one's really easy. Y is 1 plus 1, so y is 2. So I'd say solution is 1, 2. Now, I would highly encourage you check your work. So whatever equation you do not substitute into, I would plug in. And so let's see, 4 times x, x was 1. So 4 times 1 is 4. And then 4 plus, and I just said y is 2. So I have 4 plus 2 is 6. That works. And then also 1 plus 1 is 2. So I found the set of point, well, the one set of coordinate, someone just joined, such that this makes a true statement. Number 2 is just like that one. So I have x equals. So I'll set this one up, and I'm not going to finish. So I would set this as x. So I would plug that in here into the x. And I would get 2y minus 4 plus 8y equals 16. And then you'll find the value of y, get it, plug it back in, find the value of x. So again, this one is not finished, it's not done, but I want to make sure I show you many different examples that are different. Sometimes that's what we'll do, we'll just set it up. So I need to show you an example where you have two equations and neither of them are isolated for a variable. So what I mean by that is x and y are not isolated. X and y are not isolated. So we need to take one of these equations and isolate for one of the variables, your choice. If they have a number in front of it, I would not isolate for that variable because at the end you have to divide by that number and you get fractions. You could isolate for y if you want, but then at the end you divide by 2, and I think you get negative 1/2 x minus 1/2, and you have to plug that into the other equation. So I would not mess with fractions unless you just love fractions. So I could isolate for this x. I choose the one that has a 1 in front of it. So I would isolate for here. That would be a good choice. I could isolate here. And then technically I could isolate for this y, but it has a negative sign. So at the end, when I'm solving, I would divide by -1, which isn't a big deal. It's just one extra step. So I am going to either isolate for this one or this one. Doesn't matter. Just because it's on top, I am going to isolate for the first one. So I'm going to take this. And my goal is to isolate for x. It does not have to be x, it could be y. Okay, so what I'm trying to do is I'm trying to get this by itself. Now this one's really easy. I just subtract 2y from both sides. And I get x, which is isolated now, is And I like to put my variable first. I'm going to put negative 2y minus 1. So that's standard form. So all I did was I took this first equation and I chose to isolate for this x, and I get this. Now, whatever equation you did not pick, that's what you're going to plug into. Do not plug into the same equation. It won't work. You have to substitute into the other equation. So what I need to do, I have x minus y equals 5 is my other equation. But now I know what the value of x is. And x is negative 2y minus 1. From here, I'm down to algebra 1 skills. So there's no number in front, so I could drop the parentheses. So I could just put negative 2y minus 1 minus y is 5. Combine like terms. Negative 2y minus y is negative 3y. Minus 1 is 5. Then I would add 1 to both sides. Five plus 1, 6. And then I would divide both sides by negative 3. And I get y is negative 2. Okay. Now I need to find the x value. You can pick any equation that has an x in it and solve. I'm going to pick this one because it's already solved for x. And so I'm going to plug negative 2 in here. So for my notes, I can say I'm taking this, plugging it in to there. Negative 2 times negative 2 is 4. 4 minus 1 is 3. So I would say solution is 3, negative 2. And then it always helps, at least I like the kids that really show me where their answer is. Let's double check our work. So x is 3, y is 2, or negative 2. So 3 plus 2 times negative 2 is negative 4. 3 plus negative 4 is negative 1. And then here when I plug the value of x in 3, I get 3 minus negative 2. 2 negatives make a plus. So that's really 3 plus 2 is 5. So yes, I know I'm correct. Someone asked a question. Yeah, that's fine. If you have to leave early or anything, it's fine. Okay, you're good. All right, so we have 8 minutes. I could either do another problem, or is there any questions so far? I would say if you're needing a lot of math help, I would take advantage of my office hours. I cannot just sit down with one kid one-on-one, but because like there's other students in the class. But if you just have like a quick question, please make sure you use Canvas inbox, and I will do my best to reply in a timely manner. But if you're like needing tons of support, like you're really lost, then probably emailing back and forth isn't going to do much good. So just try to take advantage of the office hours if you need help. Or you could also hop on office hours if you have a quick question. But trying to email back and forth about something that is semi-complex is kind of hard. All right, so let's go ahead and at the very least set up another one. This one, what would be a good variable to isolate for? You could isolate for y, or x. Any of those three would work. let's not solve this one. It's not that interesting, but I would not isolate for this x. By isolate, I mean get by itself. The next one. There's only one good variable to isolate for, because we have 3 in front of that one, 2 in front of this one, 6 in front of this one. So the only good one to isolate would be the y. So I'll start this but not finish. I would go, okay, let's isolate for y. I would subtract 6x from both sides. And then I would substitute into the other equation for y. So I would take this, substitute here, and I'd get 3x plus 2. And then this would be, notice parentheses, negative 6x plus 11. Equals negative 5. And then from there, you're down to algebra 1, you just solve for x. Right. We don't really have time for another problem, so I'll just finish it real fast. 3x, distribute the 2, 2 times negative 6 is negative 12. Distribute the 2 to the 11, it'd be plus 22. Combine like terms, 3x minus 12x is negative 9x. Subtract 22 from both sides. You get negative 9x equals negative 27. Divide both by negative 9. And you get x is 3. And again, I know I went through that kind of fast on purpose. So that's the x value. To find the y value, I'd plug it in, probably to this one. Negative 6 times 3 is negative 18. Negative 18 plus 11 is negative 7. So I would say solution 3, negative 7. Now, when would you use this in the real world? And we're going to have one day where we just do word problems. So we'll set this problem up, but we're not going to solve it. So Marianne and Carlos are saving for new scooters. So far, we have these two guys. Well, I guess it's a girl and a guy. We have Marianne. And we have Carlos. So far, Marianne has $9 saved and makes $6 per hour. So I would say Y. She starts off with $9. That's the constant. $6 per hour would be 6x, where x equals hours. Y will equal money earned. So that's Marianne right here, 9 saved, $6 per hour. Carlos has $3 saved and can earn $9 per hour. So he has a better job, but he started off with less. And then what we could do is we could set those equal to each other, which we're not going to do, and we could find after how many hours will Marianne and Carlos have the same amount of money. And then how much will that money be? So that how much the money would be the Y value. And then how many hours would be the X value. So these things aren't just variables, X and Y's. These aren't just random equations. We're just leaving out the words for now and just giving you this so that we're not like overly complicating things at the very beginning. But all of this comes from some sort of word problem that we'll practice.